Alright, so one of the cool hobbies I have is called ham radio. Ham is a word that is sometimes said it's short for amateur, but I think it was originally an insult that's come to mean something endearing. So, I have in front of you right here a radio from a kit that I put together, the QRP Labs QCX Plus CW transceiver. It's a lot of words. I need to tell you what all of those means. QRP is the amateur radio / Morse code way of saying low power. QCX Plus is a label, it's a model number for this particular radio. QRP Labs is a company by Hans Summer, a British fellow, and he put together these neat kits for people to put together. CW is a way of saying Morse code, and transceiver means that this radio both transmits and receives. Right now it looks like it's receiving a bunch of E's. It's not really receiving E's, it's just showing E's because it's hearing static, it's hearing noise. On the back side, you'll see we have a place to plug in a Morse code key on the left. That's the red thing right there. My headphones on the right. CAT and PTT, that comes in hand later if we want to hook it up to a computer. We have this. This is our antenna connector. The antenna connector with the little knobby part on it's called a BNC connector. It's common on these QRP radios. And this is where we plug power in. It says DC because this should have direct current power only. Alright, now our antenna, if you'll look right here, follow this around, it's hooked up to this thing. What sort of antenna is this? Well, this is not an antenna. This is a fake antenna, sometimes called a dummy load. We use dummy loads to test radios. In this particular instance, what I'm going to be doing is I'm going to be testing how much power the radio puts out. If you look closely on there, you can see that there's a bunch of these little stripy parts. Those are called resistors. There's one of these little tic-tac looking parts right here. It says 103 on the side of it. That's a capacitor. And if we look over here, actually you can't really see it. It's tucked in behind them. But there's another part in there called a diode. And the diode is actually another part. It's hooked up with the capacitor together to make a DC output. Radio, it's funny. You take DC, direct current goes into the radio, but at the antenna, AC comes out in the form of a radio signal. And what this little circuit right here does, you can see that, oh, there it is. There's my little diode friend. My little diode friend back there is taking, and my capacitor is taking the AC from the radio signal and turning it back into DC. And we can measure that voltage, that DC voltage. And that DC voltage will tell us how much power is actually being generated by my radio here. Now, how's all that work? Well, a lot of it is just science. It seems like magic. But what I want to do is I want to transmit a signal, and I can't really do that and hold the camera at the same time. But what I would do is I would put this red part right here on this little pad right there and nowhere else. I put this black probe down here and nowhere else and measure that voltage with my voltometer. Okay? And what that'll tell me is how much power it's putting out. I just did it. It said that it was reading at 14.8 volts. Now to calculate the power out, what you have to do is you have to take 14.8, square it, and then divide the square by 100. And if I do that, I get 3.16, I think it is, 3.16 volts. That means that this little radio right here, or amps, or watts I should say, 3.16 watts. This little radio right here is putting out 3.16 watts of raw RF power. That's pretty screaming for QRP power. This radio puts out 100 watts. So this is a regular sort of, I say high power, it's not really high power. On the 20 meter amateur radio band, I can actually use up to 1,500 watts of power. So 3 watts is not very much. That's why it's called QRP.